We are looking at a review today, looking at the packet from the final review packet problems. All right. Sam.
Okay. So, Sam Amick knows there is a relationship between the number of cars he washes and the time it takes him to wash those cars. Identify the independent quantity and the dependent quantity in the problem situation. And I did exactly that. Independent is time. The dependent I forgot to write, but it is the cars. When it comes to independent and dependent problems, the independent variable is usually defined by time. The amount of cars washed is defined by the amount of time it will take to wash them.
Thank you, Mr. Amick.
Welcome.
Hey, Miss, we gotta explain why.
Yes.
Okay. Alright, so let's see. Imogen rode her bike to the park. After staying at the park for a few minutes, then she continued to ride to the grocery store. Then the graph shows the relationship. In the graph, what is the dependent quantity and what is the dependent quantity? Well, normally the independent is the time because the distance she goes relies on how far she goes. So that's why I chose independent as time and dependent as distance.
There's another thing about graphs. Where on the graph do you usually find the independent variable?
On the y-axis.
On the bottom, and the dependent is what you're watching go up and down. Okay, on the Y. Thank you, Andy.
Yeah.
Christopher.
Simplify. Yeah, 12 plus 1 times 8 minus 2. First you do PEMDAS. It's parentheses, exponents, and multiplication. So you multiply first. 1 times 8 is 8, so 12 plus 8 minus 2. And you have to work from left to right for the add and subtract. And first you add the 12 plus 8, which is 20, and then you subtract 2, and the answer is 18.
Thank you, Christopher.
So for problem 4, I use PEMDAS. I did 4 minus 2, which is 2, times 9 plus 11. Then I multiplied 2 times 9, which is 18, plus 11. Then when you add them in, supplement them.
Thank you. So she did the subtract because it was in the parentheses. Then the multiply because that's what comes next in PEMDAS. Then we were down to an 18 plus 11. Thank you, Jacqueline. Molly has been absent. Imogen.
What's up, boys? Do I have to walk up there? Is that mandatory?
You could stand up.
Okay, so Calvin walked from his house to school. He was at school for several hours. Then on his way home, Calvin walked to the park. He was at the park for an hour. Then he walked back to his house. The graph shows the relationship. And what in the graph, what is the independent quantity? The answer is C, time in hours. This is because the distance depends on how long it takes for him to walk. I didn't read the problem, so I didn't realize that he went to school first. And how many breaks he takes during that time he is traveling. So that's why there's obviously that really big time span. Time is almost always independent. So.
Thank you. And there's some extra choices in there that you don't really even get off the graph, yes? Be careful on multiple choice. 49ers.
Not bad.
Hey, you're hooked in.
How many games they won this year? I
don't know, maybe.
Like 1 game.
An elevator in a high-rise building moves upward at a constant rate. The table shows the height of the elevator above the ground floor after various various times. The independent is time in seconds, and the dependent is height in feet, and the height depends on the time.
Thank you.
And an expression that represents the height for every time t is in the last row, which is 12t, and the function notation to determine the height of the elevator at a time of 14 seconds is 14 times 12 equals 168.
Good. Martine, how'd you get the 12?
The 12 from
You got it from the table,
table.
right?
Yeah.
Show them on the table how we get a 12 out of there. Walk over and point to it.
What, the 12?
Yeah. Well, at time 0 you have 0. At
Zero.
time 1 you
We
have.
have 12.
At time
And
2.
2 you have 24. And at times 3 you have 36.
So where do you see the 12?
You have to add
At 12 every
time.
It goes up by 1 second, right? Is that how you got it? Yeah. Okay, great. Thank you. Jerry had 5 problems in one. He's showing the worked out version for one of them, but answers for the others.
Okay, so for this one, you add 1 to cancel out that one to get x by itself. Then you get 2x equals 12. Divide both sides by... Oh man, I screwed up. That's supposed to be a 2.
Yeah, that's okay.
And then you get x equals 6. And then the other answers are there.
Okay.
We'll have to explain this
So
too.
solving equation ones, he showed you some steps. The main goal is to get the variable by itself and everything else on the other side. Thank you, Jerry. I'm going to fix that for you because I know it's bugging you. Divide by 2. There we go. And present. Oh, Mr. Markinson. Got a nice chameleon going there, but let's see what he has. Find the slope of the line, and he says it's 1/3. The line, if I go from here to there, you have to go up 1/3, up 1/3. And it was hard to get that line. It's better on your review packet than it is on here. We had to copy and paste on the graph and the line came separate. But finding your slope on a graph, you look for places where it exactly crisscrosses on a grid, and then you say how far up and how far to the right do I have to go to get to the next place where it exactly crosses on a grid. Whoops.
Okay, so first I put the y2 and the y1 on the top, and I subtracted them, which is 5 and 2. And then I put the x2 and the x1 on the bottom, which is 6 minus 1, to get my answer with this as a slope. And I did the same type of setup for part B, and the answer was -7/9. That's the slope.
I want to show you something to be careful of. So first of all, these are the y's on top and the x's on bottom. That's one thing people make a mistake with. Here's another thing. Here's y2 and here's y1. That's great. 5 subtract 2. All right, and then look at this. This should be x2. Okay. And this is x1. So she went 5 minus 2 on top, but she went 6 minus 1 on the bottom. And there was some issues with the negative. So this one should look like, and this is okay. I'm glad you made this. You put that in there for us to illuminate how hard it is to keep this straight. 5 minus 2 is exactly how she started out. Then it should be -1 minus 6. So if she went this way, she has to go that way with the x's as well. So this should be 3 over, keep, change. A lot of times in these problems you have to do some integer work. Be careful with your positive and -7. Okay, so the 3 is great, but the -7 was difficult. Let's see what happened here. -4, 3, good. -4, subtract 3.
Did you ready to go to visit or?
Mr. Giddy, we got a couple little reading buddies, and we were giving them a little tour. Do you mind if they come in here for like a quick minute?
Yes, of course. This one on the bottom is done correctly. Okay. Hi guys. How's it going? Hi guys.
Another one.
Are you shopping around for a new school? No, not yet. Not yet. Just coming to see what these guys are doing.
All right, kids, everybody say good morning, Mr. Getty.
Good morning, Mr. Getty. Good morning.
All right, Mr. Getty is here, the math teacher and science teacher. So, Mr. Getty, you want to let them know a little bit of what you do?
Yeah. When you come in a couple of years, this will probably be your first math class. For a lot of you, this will be your first math class. Right now, everybody's getting ready for a final exam, so they've been doing practice problems a lot, and they made a presentation to show each other and share what we do. But we also do science here. You can kind of see all the sinks and gadgets, all right? So a couple years of science you may be here. So it's nice to see you guys come down. Take time out of your day. Thank you. Thank you.
Everybody say bye, Mr. Getty.
They're good. They start
Children are so cute. What happened? What happened?
A couple hundred visitors.
All right. Thank you, Isabella Christian.
How do you value just bring it up for just that? How do you value the function for fx equals 31.5x minus 17.7? And what I did is I plugged in f for x, multiplied them, and then subtracted.
Thank you. So, in an evaluate problem, you're given a value for a variable, and you plug it in and simplify. The first one, they plugged in a 6.2. Second one, they plugged in a negative 27. One key thing to know about this is on one side of the equation, and it's just a symbol. You don't actually multiply or divide the f. You leave it alone. Do we need to have people put their screens down? Okay, are people, if you're looking at your screen for this project, that's appropriate, but if you're doing something else, not the best use of our time. Thank you, Mr. Green.
Okay, so the first thing I did is keep change. So then it'll be negative 7 plus negative 6 equals negative 13. And the 13 turns positive, because if there's a negative inside the absolute value, it turns the opposite, which is positive. And 36 divided by negative 4, I just obviously divided, and it'll be negative 9. But since there's a negative inside the absolute value, it turns positive. So
Thank you. Awesome, great. One key is like an A. Don't get rid of those negatives until after you've simplified it down to one number.
Function f of x equals 7.35x plus 3. Plug negative 4.3 in the function where x is, you multiply, then you add, and your final answer is 1.6.
I like the way she left this right here. This is what I was talking about. Some people think that's something to divide now. No, leave this. This just tells you this is the function when we've plugged in 4.3. That's the way the answer should look. Good job, Hannah.
Yeah.
Oscar.
Kenya has 150 to spend at the shopping mall. She decides to buy sweaters and pants with her money. Sweaters cost 35 each and pants cost 20 each. So for A, you have to make an expression. So 20p represents $20 for each pair of pants, and 35s represents this $35 for sweaters, and 150 is the amount of money she has. And for B, it asks how many pants could she buy with 3 sweaters. So the answer is only 2 pants. And for C, they ask if they bought no pants, how many sweaters did she have to buy?
Well, it would be nice to see how you worked it out there, but maybe you can tell us. For B, how did you figure out 2 pants?
I multiplied 35 by 3 and subtracted by 150 and divided by 20.
Okay, good. So there was some information given for part of the shopping. You plugged it in, times, saw how much money that was, subtracted to see how much money was left. Then you got to divide based on the item. Thank you, Oscar. Ernesto.
The equation 2x plus 3y equals 9 is slope intercept. So I put the equation and I subtracted both sides by negative 2x. Then the answer I got there, I divided them by 3.
Let's finish this. Okay. So divide by 3. So here it is here, but it wasn't showing up on my other things. I thought maybe I need to just refresh. Refresh. And then present. There we go. There's the last step. So he divided by 3 and 4, and then he has, that's 3 minus 2/3 x, and he decided to move things around to make it slope intercept form, and he brought the negative 2/3 forward. Okay, so slope intercept form is that y equals mx plus b, and it's just moving things around to get the y by itself. Thank you, Ernesto.
So I needed to get the y-intercept for the equation, and I subtracted negative 4x because I had to get negative 3y by itself. And then I got the equation, and then I divided by negative 3 each number, and then I got that.
Okay, so what's the y-intercept? That's the slope-intercept form, and I can easily see what the y-intercept is. Good. So the y-intercept is that 6. There are other ways to get that, but that is one way. Tony.
Alright, so I had to find the x and y intercept and graph the equation. The first thing that I did was to find x intercept. You divide 10 by 2 and x equals 5. Then you divide 10 by 5 and y equals 2. Then you put a dot on the 5 on the x-axis, and then you put a dot on 2 on the y-axis, and then you get a ruler and you make a line that crosses.
Okay, so for the, what he's talking about, for the x-intercept, you say, what happens if this is 0 and isn't even there? Then divide both sides by 2, it tells you what x is. For the y-intercept, what if this is 0? Okay, and it's not even there, so then you're dividing by 5, right? Mamo, can you put that screen down, please? Thank you. Uh-oh. Mr. Craig, you put that one in there?
I don't have access to it.
Okay.
The formula,
Brian.
the formula for an account that earns simple interest is P equals PL plus PL times RT, where P represents the balance in the account after T years. P represents the initial deposit and R represents the interest rate Danny deposited $1,000 into an account that earned 4.25 simple interest annually. How much was in his account after 1 year? So what I did was put 1,000 plus 1,000 times 0.0425 times 1, and then I did the parentheses first, which got me to 1,000 plus 42.5, which turned out to be the answer was 104.2.5.
That's a nice bank account that Danny has. First of all, $1,000, and then 4.25% interest. That's a nice bank account. Danny is one of our 8th graders.
The formula for an accountant that earns compound interest is PT equals POX 1 plus R times life by time, where P represents the balance in the account after like years it will take, and P represents the initial deposit, and R represents the interest rate. So Ernesto deposited $300 in an account that earns 6.25% compound interest. How much will be in his account after 6 years? Round to the nearest cent. I put P of 6 into my calculator. Equals 300 times x, and in parentheses I put 1 plus 0.065, which is a rate, interest rate, and I times it by 6 years since the time was 6 years. For an answer I got, he will have $431.61 in his account for 6 years.
It's a nice bank account too. Just sat there for 6 years, but it earned $131 just sitting in the bank. Wyatt, Chris.
Lions Cook offers a membership to take cooking classes for an initial fee of 60 plus 20 for each lesson. Professional Cooks offers a membership to take cooking classes for an initial fee of 15 plus 35 for each lesson. Write a system of equations to represent this situation. After how many cooking classes will the cost of both companies be the same? So at first we want to get both equations, and then we want to plug the other equation to the other side, and then we want to get x to the left side, so you subtract 20 to both sides, and then you subtract 15, so then you get 15x equals 45, and then you divide that by 15, and you get 3, then you plug that in to either equation, which is a property. So then if you do the equation, and you put 60, that's 120, and then you are equal by 3 lessons, and equal as for both of them.
Okay, now take a look at the problem. Finest Cooks offers classes for initial fee of $60 plus $20 for each lesson. How do we know which one to put with the X, the 60 or the 20?
It's the additional price.
The additional price, and it's per lesson. Okay, so that's why it has a variable. It'll depend if there's 1 lesson or 2 lessons or 3 lessons. It can change per lesson. The flat fee or the initial fee is $60. That doesn't change. You're going to pay 60 if you have 1 lesson. You're going to pay 60 if you have 10 lessons. So a lot of things in life, there's a flat fee and then a certain part that goes up or down depending on how much you use it. Ruby, Natalia, and Eli. Okay, these are some of our 8th graders. This problem, let's see what they did. So they took that, and it looks like, wait, here I don't know what they're doing. Let me see. They moved, they subtracted a 1, added the 2, and then divided by So they got x by itself in this one. Okay, so they said, hey, I have x by itself right here. So they took this top equation and rearranged things to get x by itself. They moved over the 2x, they moved over the 1, then they divided everything by 2. Then now you have this equation and this equation equal to x. So they set those two equal to each other. And then worked to solve for y. 2.5 equals, y equals 2.5, y equals 1. Brought the 1 over, plugged it on in, and came up with an x of 4. There's different ways to go about that one, but that is one way. And then that looks like some are unfinished. All right. Questions? Any other questions on your packet? Okay. What we're going to do now is you're going to start, but you don't have to finish, your partner exam. For this partner exam, Chromebooks need to go down and into backpacks. Phones obviously should not be around. I want the yellow review packet brought up here right now.
Lord.
You're going to spread out in pairs. Spread out in pairs.
Hey, you forgot to pack that your paper. Partner, not three-way.
There are rulers up here. You and your pair should have at least one calculator and at least one ruler. Yes. Well, let's see after everybody spreads out, okay? I want you to attempt to spread out first. Yes.
Do you have a pen or yeah, just a pen like the box?
Okay, have a seat, please. So there's somebody without a partner. There's 2 threes. So come on, make some partners, please.
It's 2, not 3.
Okay, now, the other thing to know is this test, I had a printing snafu, which is probably maybe just perfect. There's 3 pages here, and then for some reason the other pages didn't print the first time I did, so they're in a separate packet that you're going to have to staple on. But we'll start with these pages and see where we're at with time. You and your partner may be ready for the additional pages. Maybe that'll take place on the final day. Okay, so we're starting the final now. It will roll into our final exam period. But there are some blank pages and more pages to come. Sam and Mabel or Imogen and Alex, one of you groups go to somewhere else, please. Well, I see 3. I got 2 of them there. 2 humans. Maybe we need to talk to them.
Here, you get your own.
Sorry, Chris.
You can do your work on blank pages, you can write a Christmas tree, you can do what. But once you get to the blank pages, I have more.
It's a different graph.